We had been talking about the octet rule and how to draw Lewis structures. And now I just need to, this is kind of a disclaimer, inform you that there are exceptions to the octet rule. I'm not going to test you on these, but they'll show up in the homework, and they may show up sometimes in lecture, and I just want you to be aware that that's not, that we did it wrong, but these are exceptions. So there are some molecules that it's impossible to write good Lewis structures for because they have an odd number of valence electrons. Examples of this, one example is nitrogen monoxide. So the nitrogen brings 5 valence electrons, the oxygen brings 6. 5 plus 6 is 11. How do you make pairs out of 11? You can't. Okay, so you can't write a great Lewis structure where everybody has 8 valence electrons, an octet. And so we just do the best we can, and so you could write it this way or this way. And there's actually a reason why we give oxygen the octet and not nitrogen. It has to do with electronegativity, which we'll cover at the end of this chapter. So I'm not going to be asking you to do any of those on an exam, but that's an example. Another exception is boron. Boron tends to form compounds where the boron only has 6 electrons instead of 8. You know, he's one of those little guys. He's element number 5. And he's kind of stuck there in the middle of period 2. And so he tends to form compounds where he only has 6 valence electrons, and he's okay with that. He's like willing to settle for 6. So that's one of the common situations we'll see where we have less than 8. So boron trifluoride, boron trihydride, we got 6. Other examples are where we have more than 8 electrons, more than an octet on the central atom, and these are called expanded octets. Examples are sulfur and phosphorus. They do this sometimes. Here in sulfur hexafluoride, sulfur's forming 6 bonds. Okay, they each have 2 electrons. That's 12 electrons around the sulfur. But sulfur is a larger atom. It's in period 3. And it has d orbitals that it can expand into. The period 2 elements never form expanded octets, but the period 3 ones can do that. And phosphorus is also in period 3. It's a little bit bigger, and so it can handle 10 electrons instead of 8. So just so that you're aware that those exist. There are exceptions, and Lewis theory doesn't work for everything, and yet it's still very, very useful because it's easy to understand, and it works in a lot of situations. So it's still a good theory.